Okay, this is chapter 14, lecture 2. We're on part 2 now, and this is the first part. So we want to look at page 36 of our lecture guide, and we want to discuss how to choose a buffer. Okay. Now, the basic idea is that you have a pH in mind, okay? And this will be given to you in a word problem or whatnot. And then what you need to do is locate a buffer where the acid has a pKa about equal to the pH, okay? So in other words, how does this work? Why? We use the Henderson-Hasselbalch equation to predict or calculate the pH of a buffer, okay? And if the base concentration is equal to the acid concentration, let's say they're both 1 molar or they're both 0.25 molar, then the pH will be equal to the pKa plus, log of 1 over 1. Log of 1 is 0. You can hit that in your calculator. The pH will be equal to the pKa. Okay, and you kind of estimate it, okay? So for example, what acid and base could make a pH 10 buffer? So we recognize that the pH is 10, and we want to find something where the pKa is close as possible to 10. So we come back up to our appendix, and we're looking at this column right here, and I see pH 10 is right here, 10.3 technically speaking, right? Very close. So these are the chemicals I'm going to pick out, okay? HCO3 negative is going to be the acid. CO3 2 minus is going to be my base. I forget what I was even saying. CO3 2 minus was the base. Now these items as written are not purchasable, so you want to write the sodium salt for this. And the way you do that is you recognize that sodium is in group 1 of the periodic table, and it has a +1 charge. And then you want to write down the, the charge of the polyatomic ion, and you want to crisscross. There's one of each, so we just slap the formula together. NaHCO3. So that's one of the answers. Carbonate is a -2 ion. So position these nearby each other, okay? And you want to do your crisscrossing here. So what we do is we bring the 2 down to make Na2CO3. Okay, and so that would be the other answer. We don't want to write ions as an answer. We do recognize those are the polyatomic ions that act as a weak acid and a weak base, but these are actual chemicals that you go to the stockroom and try to purchase or mix together. Okay. Next question. What can be used to make a buffer of pH 5? So first step, pH is 5. Next step, pKa. We want this to be about 5. So we come back up to the table and we look at this column and we see this one's pretty close, okay, 4.74. So we want to mix this chemical, which is called acetic acid, and some chemical that has that ion, which is acetate, okay? So we could use acetic acid and sodium acetate. You could write words or formulas. Okay, either way, so this would be one answer possibility, this would be another answer possibility. Remember, you always need a weak acid and a weak base, so that's the idea behind that, okay? All right, let me give you a couple problems here, which I'm sure you'll do just great with, okay? All right, so what chemicals could be used to make a 4.5 buffer pH is equal to 6.5 buffer, or a pH is equal to 3.0 buffer. Okay? Fill those in on your worksheet, and I'm assuming you're watching this and following along and attempting to do these problems.